Good afternoon. Let me introduce myself. My name is Javier Uceda. I am the rector of this university, Technical University of Madrid, rector of, if you prefer, the president, as you used to identify the head of the university. And it's my pleasure to welcome you to this university. You have been the whole day in our Forest School of Engineering. I know that just the day before you were in Avila. I hope you enjoyed that city, and that the day before just in the National Distant University here in Madrid. Again, we are very glad to co-host this event, and we are just going to the end very fast. This is the last session, the last presentation. I see still there are many people here. I expected not so many people in Friday afternoon, but it's nice just to see all of you here. And for me, it's my pleasure to give you my warmest welcome to the university. Formally, we have the closing ceremony after the last speech, but unfortunately, Vice Rector of the National Distant University, Mercedes Boixareu, could not attend to the closing ceremony. She is going to Barcelona right now, and she's going to say a few words just to you before the end of the conference. Mercedes, please.
Yes, thank you very much. Really, I regret not to be here for the closing ceremony. And just to tell you that I hope these days in Madrid have been useful, fruitful, as well as pleasant. Then, the university, the UNED, is at your disposal, Professor Castro and all the institution, and we keep in contact with you for further collaboration. Then, thank you very much, and I regret again not to be here for the closing. Thank you very much.
Okay, and I'm going to pass the floor to Professor Edmundo Tobar.
Thank you very much, Rector. It is my pleasure to introduce to the Professor Javier Uceda. Javier Uceda received the master and doctor degrees from the Universidad Politécnica de Madrid, Spain, both in electrical engineering. His research activity has been developed in the fields of power electronic and digital electronic systems, where he has participated in numerous national and international research projects. Currently, he has been elected as rector of this university in March 2004. Dr. Uceda is currently fellow of IEEE and a senior ADCOM member of IEEE Industrial Electronics Society. Has received several individual and collective awards, among which stands out the IEEE Third Millennium Medal. So I would like to stress another thing that under his directory, he has promoted the engineering education in this university. He has launched calls for programs for educational innovation projects. He has promoted to the elaboration of an educational model for this university. So I think that this is the more adequate person to close this intensive and productive and enthusiastic conference. Please, Dr. Uceda.
Okay, thank you. Well, again, good afternoon. Although according to the standard in Spain, we should say still good morning by lunch. And just good afternoon after lunch, still good morning time. So according to my lunch is waiting for closing the session. And I hope the same to you. So according to the standard in Spain, we can say good morning again. Well, first of all, I would like to thank to the organizers for inviting me to participate in this conference. It's for me a privilege and an honor to be just at the end of the conference having this invited speech regarding a rather general topic, innovation in engineering education. It's just the whole scope of the conference. You have been discussing during the last 3 days about a lot of very specialized topics. I have checked the program just a few days before, and I have learned that you have a lot of interesting topics, just in some cases in the classroom, in the labs, using information technologies applied to engineering education or many others aspects related to engineering education. It's a very complex and sophisticated program. And for me, it's just very interesting. I have this opportunity to give you my thoughts about this particular topic, but at the same time, it's a challenge to keep your interest along the next 20 or 30 minutes. According, this is the last session. I know that you have finished yesterday very late. Somebody told me that you finished your session yesterday around 1:30 a.m., and it's something too difficult to stay awake just today, just at that time. But anyhow, I have prepared just a presentation that necessarily, according to my last experience, have been during the last 6 years rector of the university, so my work has been directly oriented to administration of the activity in the university rather than like a professor that it used to be in the past. And probably my presentation is contaminated from this point of view, from the one which is responsible for the administration of a university like that. But anyhow, I'm going to give you an overall impression about what I call engineering education, probably for you that you are clearly a specialist on the topic. Probably you will go in more detail, go down in more detail, but well, anyhow, I prefer just to give you what are the highlights in the topic according to my personal impression. And if we have the opportunity to discuss after the presentation, I will be very happy to answer, to give an answer to your question or comments you have related to this topic. So the outline of my presentation is very simple. First of all, I would like to give you what, according to my view, are some of the engineering challenges right now. In general, not in education, but there is a clear translation from those challenges to the education activities in order to, try to solve the problems or the target or the objectives that we have in those challenges. At the same time, I would like to say a few words about what we can identify like emerging fields in engineering. That means these new areas identify new topics, new toolbox in engineering, and are creating a new area where also we have to continue working from the education point of view in order to get into those new fields in a proper way. At the same time, there are also the social issues. I mean the social issues regarding to engineering education, how to deal with those elements, and I identify a few of them, like those related with sustainability in engineering, or those related to globalization aspects that are just important, transferred to the activity in universities related to those topics. And of course, we need to talk about educational models. That is probably one of most of the papers are related to those aspects in the conference, and we need to talk about that. And I would like finally to elaborate some conclusion, just in the very summarized presentation that is basically what we have here. Well, challenges in engineering. Probably we can open a bit discussion related to this topic because there are many questions to be addressed and probably some answers to be found in order to discuss this point. But I have identified three main elements. Number one, that's identified with that sentence, that engineers need to understand the structure and behavior of the matter from nanoscale to extremely complex system. What I mean is that the scope of engineering is becoming wider. And this scope is widening. It's becoming bigger. And there are areas where just before we didn't work as engineers, and now we need to. And something that is modifying some of the activities in education. At the same time, complexity is another key word, according to my view, because engineering problems are becoming more and more complex. It doesn't mean size, complexity doesn't mean size, means complexity. Also tiny things could be very complex. and integrated circuits, having 10 million transistors is a complex system, although it's a very tiny component. At the same time, probably in the other extremes, things like networks, big networks, internet, or just other networks are just another example of complexity, and we need to, to work with those complex structures, and I would like to elaborate in the comment on that. Second element, of course, engineers need to use intensive application of computer model tools, looking for something that is crucial, productivity in the design, construction, and operation processes. That's also another key issue we need to develop, and our interest in education is looking for what we call increased productivity through the application of those models, elements, and tools. That is something that is important to get for the engineers. And engineers need to be sensible to what I call social changes. We are just part of the society. We are not working isolated in the bubble. And we need to, to consider some of the elements that are affecting the way of designing, manufacturing, and operating some of the typical engineering matters, whatever they have, they are. And this is all these three challenges. Of course, we can add some others, but at least three are, from my view, some of the key challenges in engineering. And there is a clear translation for those challenges to the engineering education, and some innovation in engineering education should be connected to those challenges in order to solve or to face those challenges properly. And if we go to the scope, let me highlight some few ideas. Number one is that as are new, let's say, emerging fields. Of course, they are not emerging from the point of view of research, because they have been working for many years, but now they are just very active in engineering education, in the undergraduate and in the graduate curricula. And it is something still new things, new elements. And of course, the micro and nano world is something that is now becoming more and more important. I would like to comment later that there are many universities right now offering bachelor and master courses in those areas, but some elements should to be considered. Also, the clear connection between engineering and life science is just something that is going to be, in this 21st century, one of the key issues. So the connection between engineering and life sciences. And finally, what I call complex system engineering, which is something which adds additional problems related to complexity. On all these three are three examples of the possible new fields, emerging fields, from the point of view of education that we need to consider. And we will look at some of those. For instance, of course, this is very often, you look at you look at the web page of many universities today, and it's quite easy to find programs, bachelor or master level, devoted to micro or nano things in the micro and nano world. But what is important is that some of the topics that typically didn't appear in the curricula now are appearing. For instance, just an example. Now, if you look at the MIT subject for undergraduate students, they offer something like a molecular mechanics. But it's something that I don't know how to do that, so I'm not familiar with the topic. So those things need new way of facing those areas. And exactly the same area, a new toolbox. That's the key element. New way of analyzing, a new way of a new computer model required to understand at the nano scales, because clearly, so the rules are different. Gravity is less important. Other atomic forces are appearing in the design of those elements, and they're interesting problems to be solved from the point of view of education. And an interesting example, there is an article that is just indicated down, Silva. Some examples of how engineering and nanotechnology are related in education. There are some good examples where just those nanomaterials and nanodevices can interact with cells and tissues. at molecular level, allowing a high degree of functional specificity. That means that there is a chance to do different things using those elements at that level. Different toolbox are required. And some concept like cell assembly of molecules that I told you before, that's the reason of molecular mechanics that I mentioned just in one of the subjects of MIT, or growth artificial bone, or drug delivery using nanoparticles. That is something that is becoming, in the next future, is going to be a possibility. And there are also some different problems because the spatial and temporal consideration are different. This is just nanometers and femtoseconds are the variables at that time, and the problems using those at that level, at that scale, are different from the one we have using different scales. And one of the conclusions in this article, and it's very well elaborated with more details, is just to say, okay, new visualization, characterization, manipulation, new models are required. We cannot do that using the standard models we have. We cannot use the standard tools. New tools are required. That means that finally, in education, new tools need to be transferred to the students in order to enter in this field. This is something which is happening, and I took just one example for the web from the University of Alberta. There is an electrical engineering bachelor program with a major in nano engineering. And those courses are just typically appears in the area. So, new fields, new topics, new toolbox in order to solve some of the new problems that appear in the engineering education as well. At the same time, complexity, another key element. What does problem means? Of course, historically, engineering, the level of complexity is increasing continuously. But the problems that appear that are now as a consequence of the level of complexity are also new problems to be faced, new problems to be solved. What I mean complexity means many things. I gave some examples before, but also I mean classical elements. For instance, if you consider an automobile, a car, it's a very well-defined device. It's a complex, of course. There are a lot of elements into the system in order to be designed, but you can't consider the automobile as an isolated element in the next future. It is something to be in connection with the rest of elements in the highway and communication with the highway in order to provide information for driving on any other activity regarding the traffic. And also at the same time, there are connection with other network, data communication and so on and so forth, and the whole system has to be operating in those networks with those elements together. So that means that the way you transfer to the students the concept and ideas should to be modified considering the new system level operation of some of those elements into this new way of operating in the case of traffic, automobile, highway, and so on and so forth. This is something that is clear. At the same time, the level of complexity of other elements like the network science, is that's something also that is just growing and growing in order to try to understand the behavior of those complex structures, and it's something also very important, and so on and so forth. So that means that the level of complexity is becoming so new ways, new problems, new topics, new ideas. And system engineering is becoming more and more important. So it's nothing new. System engineering is just for many years, it's forming part of the curricula in engineering in many universities, but it's becoming so more important according to the level of complexity of the engineering problem. So there are many programs today. If you look everywhere, most of universities are offering courses, programs at master level oriented to system engineering. But so there is new ideas. When you have a system, a complex system, very often it's difficult to foresee what is going to happen in every condition. So complexity means that all the possible occurrences need to be identify if you want to have a clear answer to all the operating conditions of the complex system. But practically, this is impossible when you are just considering the very complex system. And there is now a discipline that is just how to deal with those that they call emerging properties of those complex systems. That you know what is going to happen, and it's very often in the electrical utility system. Sometimes happens something that you didn't expect to happen. So it's happening because the combination of things that you never foresee, it's just happening, and that's one of those emerging properties is apparent, or just in a very complex chip. It's very difficult to see what is going to happen if one of the transistors fail, every possible combination of those fails, and what is going to happen with the output according to this emerging behavior that is important to be identified. Saying again that, and now they are also in engineering a discussion that this is a classical discussion, that in education, not only knowledge, science-based knowledge, is the right knowledge to be transferred to the students, as it used to be today. Science-based knowledge is one of the guarantee that the design, operation, and manufacturing on any system or device is independent of the designer. So because you are using the same rules and everybody is just getting the same outcome, if you make the computation of the structure of the building, everybody can do it using the same tools. But when you have the system at a certain level of complexity, sometimes you need to use a set of rules that are not based in science, are based just in the practical application of that some concept, it's not based exactly in science. It used to be in the past, for instance, if you go to the Roman Empire, at that time they are able to build very nice bridges. You look at still, they're just working. Some of those bridges built by the Romans a long time ago. But at that time they don't have enough information to compute all the data required to make a right design on the bridge. And what they do at that time, they have a set of rules, some kind of proportion between this and that, in order to guarantee that the operation of those elements works properly. Now, again, there are some known structural knowledge you can apply to those complex activity, and this is something to be considered also in the education of engineering programs. Of course, engineering and life science, of course, is probably the more classical examples. There are most of universities, or many universities in the world are now offering programs in bioengineering, and it's becoming, you know that the most promising technologies for this century, 21st century, are those identified typically by NBIC, N from nanotechnology, B stands for biomatters, biotechnology, I stand by information technology, and C stands for cogno, the operation of the brain, or the human brain, or just the operation of machines looking similar, behavior of the human brain. So nano, bio, info, cogno are some of the key technologies, and exactly is going to be translated to engineering education. And in education there are many courses on that. But something which is still rather new, so biology is going to be a common subject in engineering. It's not yet. Typically, every program engineer has mathematics, physics, or chemistry, computation everywhere, but probably not biology everywhere. And now if you look at, there are more and more universities including biology as a common subject for everybody. It doesn't matter where your field of engineering, but biology is something to be understand the interaction between the devices and humans. And this is something that is also changing. Also, is now a new and multidisciplinary approach between medical schools and engineering faculty is now very, very common in many universities, and this is one of the key elements of this transformation. At the same time, the interaction between what we define like biosystems and engineering devices requires additional knowledge. That's the reason, because new courses have been taken to the students regarding all these topics. And, well, it's just more common that in some occasions, some of the engineering problem could be solved by re-engineering, biological solution. Yeah, this is something that's happening more and more often in the world. So let's go to the social sensibility, regarding what they call sustainable development. What is something that is just clearly increasing the sensibility of population to those matters, especially in some regions of the world, in the so-called developed world that I put it here, that I mean that in some areas the sensibility is different from the others. It's clear to everybody what I mean, but in practical, but what is true in some regions, this is something very important to be included, to be transferred to the institution, to the universities as a whole, but especially to the engineers and to the students. And what means sustainability? In engineering, is something which is very well defined by United Nations. I put it just some clear sentences what I mean. But in any case, it's not important now. The discussion related to this topic is here, and we have to consider this element. And there are some people defining clearly some of those rules, and in just an examples to give you what I mean with sustainability in engineering is just the document created by the UK Royal Academy of Engineering, where they define clearly in a very nice document what they are the rules to define the practical engineering with those sustainability principles in the daily operation. And that some of those elements are just summarized here. I don't want to go down all these elements because the time flies and my time also flies. But that they're well defined, and it's very nice just to have a look to that document in order to understand what kind of things implies in terms of the engineering practice, in terms of the engineering education related to those elements in sustainability. Some universities just have defined a clear commitment with those elements, and particularly I have taken the examples of the University of Glasgow, where they have defined a whole policy for the whole institution regarding to, well, transmit those concepts to everybody. I mean, not only to the students, but also to the staff, and also to the community. They feel themselves like a sustainable support institution as a whole, and there are some elements, some principles, some of them are described now in the slide, but what they try is just to develop, to create, to change the culture in the institution in order to consider as part of the institution those concepts apply to the activity of the university. Of course, they plan to embed sustainable development in the curriculum, but also they plan to do these things not only for the students, but also for the staff and for the management and so on and so forth in the whole university and with the society around the university as one of the key elements to be transferred to the whole society. And well, some of the elements are defined here in the slide. I don't want to go down all the details. It's easy to understand, I mean, the concept. And well, that's some of the examples. Everybody here, again, here in this university, also we have not so well-structured plan that the University of Glasgow has, but we have been working on that concept everywhere, trying to be sensible to those elements in the curricula of our graduates. Globalization, another issue that is affecting engineering education. It's just, which is not globalization in the general sense. I mean globalization of engineering activities. Of course, globalization is affecting everybody, everywhere, and every activity. It's just, but also engineering as activity. I mean those companies trying to able to build everywhere a power plant, a highway, or a factory. Those engineering activities are also becoming more and more global. And there are some data, and the source of those data is a very nice report by the company, Apex Engineering, just regarding this point, globalization of engineering. And they say things like that. And for instance, they say that in 1990, 40% of the world engineering work was in USA, but now it is clearly things are changing a lot. That means that things are changing very rapidly, and there is a process of they call offshoring engineering activities. That means that, well, they are able to do everywhere. And also it's changing a few important numbers. That means that the engineers and the number of engineers that you require here and there are moving very fast. And just before, you need engineer here and you need engineers there. And the number of engineers, the numbers in terms of quantity is also something which is changing all over the world. I say as a consequence of those changes, where the activity is located. And this is another reason, because accreditation, international accreditation, is becoming a key issue in order to know exactly how good, how bad, what's the level of those engineers here and there, and that's those general accreditation of engineers professionally, and also the programs in university is something that is becoming more and more important. Everybody is trying to get those accreditation, and for instance here, we are just on the process to be accredited by AVED, that is an American, international, fundamentally American agency, in addition to the European and Spanish agency. Of course, but it's something which is becoming more and more usual, and the relation between the accreditation agencies all over the world is just something in progress, just the cooperation. And at the same time, it's something that is happening personally. Probably in the past, when you got a job as engineer in a company, you go there, okay, say, okay, I'm an engineer, okay, very good. You begin to work in the company, and you expect that the company is going to give you the additional preparation, education required to develop your work in the company according to the evolution of the company. And this is true because, well, the company want to have those well-prepared staff in order to, well, to be elected to get the best condition for the company. At the same time, but at the same time, globalization, it changes the rules, and things here and there are moving, and very often the people need to be more individually what is going to happen, because, well, probably if the company is doing right things, that's okay, but if you are not in the right company doing right things, probably you are in trouble if those globalization movements of the engineering and other activities is happening without your control. So personally, you need to look at yourself and be concerned about the updating process of your own education according to your job. It's something that is also something to be considered. And in addition to that, there are other challenges. Of course, I have no time, but other challenges could be considered in general. And it is like administrator. That's one of the things that I put as administrator. There are continuous increments of tuition costs. I mean the cost, but not the income. And very often we are in trouble in order to guarantee that we give to our students the right things, the things they require to be well prepared. And this is a question of cost. And that is something to have to be here. This is a public institution, a part of the budget. Roughly speaking, 55% of the budget is coming from the government. The rest is coming from the students and from the external activities we have. But of course, there is we have, well, some difficulties in order to guarantee this continual operating cost of the tuition activities in the university. At the same time, also, there is a big discussion everywhere, and also here. There is the balance between those staff with the background, research-oriented background, and those staff having professional experience, because engineering is a professional activity. That means that professional experience is something to be considered. It's not just mathematics, it's something different. And those balance is also a problem that we are facing in most universities, especially those oriented to, or those who have decided to be clearly a research university, and most of the professors trying to work or trying to develop their own career doing research, and it's very good, but at the same time, so there are some difficulties to find out among the staff, those with the professional experience in engineering. I mean, not like researchers, I mean like engineers. And in some areas, not everywhere, there is a lack of engineering vocation, nor in Asia, but well, this is true in America, or this is true here in Europe at the same time, and it is something that is also affecting to the problems in engineering education, but I don't want to talk about that. Let's go now to educational models. That is something related to what you did. There are a lot of people saying that we are not doing the right things. We are not doing the right things. And I just took one of the examples. It's general. It's not for engineering. It's just the source is Nobel Prize, Physics Nobel Prize 2001. Sorry, because just the last part is in Spanish, but the rest is in English. And what they explain here is that something which is rather general, and you are able to, everybody agree about what is required. And things like the modern economy demands and reward complex problem solving. Communication skill in technical subject and complex problem solving skill are frequently attached with traditional teaching practices. It is something that is very concerned to this Nobel Prize called Wake Women, and there is a program related to physics trying to solve some of the problems mentioned in this sentence. At the same time, and this is more recent, there is the National Science Foundation in the United States in a document, very interesting, saying, moving forward to improve engineering education. This is the document, and there is a very nice report saying what is, according to that organization, what are the things to be done, and they define something which is basically the same things. And if you read that, say something like, with patient system thinking, that was something that they mentioned before, ability to innovate, ability to work in multicultural environment, ability to understand business, context of engineering, interdisciplinary skills, communication skills, leadership skills, and ability to adapt to changing conditions, and an eagerness for lifelong learning. This is the different kind of engineers from the norm that is being produced now. That is something which is discussed. Everybody is saying similar things. And of course, at the beginning, there is something that everybody agrees, is that in addition to analytical skills, well, are well provided by the current education system, is something which is that everybody has said that we are doing that properly, but of course, there is some lack that we will identify through those elements. And that means that we have to modify some of the educational model, the way of educating our students. And this is something which is has been everywhere, and most universities. I have checked some of your papers. I realized that most of you are working in those ideas. In some cases, partially, just trying to solve a very specific problem, very well identified and conquered problem. But other cases, well, you try to consider in a program or in a faculty or at set a level in the university. And most of the concept at base of those ideas. Educational model are student-centered, just versus teaching-centered or teacher-centered. That's the idea. Learning-centered, problem-solving oriented, team-working oriented, etc., etc., etc. And the ideas are clear. The problem is how to implement those elements in your own university, in your own department, in your own classroom, on your own activity as a professor in the university. And those are the challenges that we are facing everywhere. And everywhere have programs, innovation, educational innovation programs everywhere. And we are doing same here. We have a very nice program. We have been for many years on that. And also some results are happening. But still, it's a continuous process, and there are some cultural barriers we need to jump, and that's, or just to remove, both, or just jump or remove those barriers. There's something which is happening. And for instance, some of the ideas that I mentioned before, for instance, at MIT, they say in the task force on undergraduate education and commons, so what are the common topics for everybody? It doesn't matter what degree they get at the end, undergraduate, I mean. And they say things like, if you look at the right-hand side, you see, for instance, biology, that I mentioned. Everybody biology. And if you look more, you say behavior of complex system. Everybody behavior of complex system as a topic. And if you look neuroscience, for engineering, neuroscience, but it's there. So they are defining new areas new subject for everybody. And they are not just in the general, knowledge they need, like the left-hand part, that means humanities, history, and so on and so forth. That is clear, that is also very useful for the people. I mean that in those areas that is specified or specifically oriented to engineering. This is that's happening, and this is some of the changes that are happening. Or if you look at this is just taken from the web, what the University of Aalborg in Denmark say about itself. Say something like, as a model of teaching, problem-based, project-organized model, and so on and so forth. You can read what exactly they are trying to do in order to increment, to modify the way of teaching, the way of learning from the point of view of students, based on those key elements that we mentioned before everywhere. Or you go to in Europe again, to the University of Twente in the Netherlands. Also, they define something similar as a general policy for the whole university, and those are university having technical programs, engineering programs, and those elements are one of the key elements in the model, in the educational model they have in those universities. And all these things are happening, and also, of course, we are doing the same. So we are doing the same. Just one very simple. We have now developing a model. That is based on these 6 pillars. That is something that is, well, simple because the sentences are very clear, but just before to end, before that, it's just, I have just a small 2 minutes video that I'm going to show you. Just 2 minutes, which summarizes exactly what it is. Okay, let's go. That's what we try to do here. Sorry because it's in Spanish, but basically it's an educational model based on 6 pillars. Number 1, it's just student-centered. That's what it means. Active education, that renovation of education methodologies, project-oriented, people working on teams, professor I mean. Number 2, internationalization, like most of the programs, with things like mobility programs, of course, for the students and staff, internationalization of the institution, international graduate school, international semester. Number 3, efficiency and quality. So we try to the reduction of the drop-offs, professionally oriented, coordination, the whole program, accountability. Number 4 of those pillars, just interested in the academic success for the students, innovation, coordinated with the high school and so on, with some programs in order to get similar level for everybody and so on, mentoring programs. Number 5 is just commitment with their graduates, that means connecting entrepreneurships, programs for that. Just trying to develop or to go for a job, networking, alumni, association, and so on. And number 6 is just open to the society. And this is social responsibility, connected with companies and industries, fundraising, and so on and so forth. And that's exactly what we are trying to implement using similar approach that we have everywhere. 6 pillars in the program. Let's move now to the conclusions. To the conclusions in my presentation. Just 1 second. That's the 6 pillars that we described in Spanish just before. And some conclusions, just very simple. After all this, as I said before, overall description that we define like innovation in engineering education, a few topics. First conclusion is that changes are happening very fast everywhere, even in engineering education. And the ability to adapt our institution to those changes, it will make the difference between those successful institutions and those not so successful institutions in the future. So adaptation capacity is something very important. And we have to develop the structure, the operating principles, the way of doing things that are able to be adapted to the changes that are happening. Now we describe this situation that probably in 5 years the situation will be a little bit different according to those changes. Number two, university need to define their strategy to face these challenges. It's not a question of a single professor or a single department or a single program. It's a question of the whole institution. They need to define it clearly. And they state their strategy in areas like emerging fields, if they want to go in those fields or just to continue in the classical studies they have. And at the same time, if they're able to get what they define like a flavor, because I don't know how to say this, those so general at implementing everywhere elements oriented to sustainability, globalization, internationalization, that are key elements in engineering education today. And at the same time, need to define their educational model. We have to define clearly that. Here we are doing that. We are just doing that continuously, and you need to reorient continuously this education model, because it's important in order to get or to solve some of the problems defined in the previous challenges. This is basically what I want to say today. Thank you very much for your attention, and that's my talk. Thank you. That's it. If I don't know, we have time.
Yes, we have time, I think, for a couple of questions. If you want to ask to the rector, some question. Any question?
Yes. Yeah. So, well, first of all, just communication. So we are just continually talking with the people at the high school, number one. Number two, we are offering tools to improve the abilities at the end of the high school for the students. So we are just providing them with some tools. In some cases, we offer them some, we call, let me say, which is the name in English. We have here an environment that we call initial point. Well, for those who at the very beginning, they want to study any engineering discipline, and they need to, well, we're able to offer them what are the knowledge they need to, and we provide some information, some proofs in order to determine what the level they have, if they are able to do that. We are just offering them to the teacher in the secondary school, and we are doing that. At the same time, we have a workshop every year with the teachers in the secondary school and professor in the first and second courses here in the university, and all those elements are trying to make a continuous system, because frankly I must say that here in Spain at least there is in some cases a clear cut between which is just the end of the secondary and the beginning of the university, particularly those who decided to continue in engineering. Probably engineering here is harder than others, and they need to to be with the level in some areas, or with an orientation in maths, in mathematics and physics and so on, and we are trying to work with them continuously and improving, and there are some programs that probably somebody else here could identify in more detail that we do that, and I think it's working properly. At the same time, for instance, we have a special program for extremely, extremely smart students. So for those who are clearly out of the standard, and we offer for them just an activity here in the university before they finish their secondary school, and they know the activity here. We offer special courses devoted to them in order to solve the problem that typically they have, this kind of extremely smart guys that they have problems to adapt themselves to the secondary school. We are just working with the secondary school as well. So that's kind of thing we're doing that. Okay.
Thank you very much for your excellent speech. Would you please?
Sure.
Thank you very much for
your excellent speech. Would you please, you have mentioned several times the sustainability, curriculum sustainable, and so on. Would you please to precise the term of sustainability, please?
Yes, sure. I did it, but I didn't, let me. I used the United Nations definition. Sorry, this one. No, there's one next slide. This one. That's what I decided. To make development sustainable, to ensure that it meets the needs at the present without compromising the ability of the future generation to meet their own needs. That's basically a possible definition, rather general, of course. You need to go down with those elements, with that means. But that means many things. That means many things. That means that energy and water and all these elements are limited, and the student need to know that clearly. It's not a question only of price, it's a question of the limitation of that. Also, all the aspects related to recycling and so on and so forth, elements we included on that. So there are many considerations to be included. As a whole, it's a change of culture in the courses. That's what I mean. It's not something, it's not just to have a subject devoted to this aspect, because it's not the way to solve that. It's similar to the activities that I would suggest to go in the examples that I mentioned of the University of Glasgow. If you go to the web page and go to the initiative, they have program, they have a list, a very long list of activities. So probably it's easy to understand the kind of program that I am just considering. That this is good examples of the programs oriented to improve the sensibility to those principles. Because at the end, so what we see is that, of course, we need that the graduates need to be sensible, but the institution itself need to be sensible as a whole, just in the operating day. And all this consideration, very well structured, are in the examples of the University of Glasgow. I would suggest just to have a look to those things, because it's a long list of activities that they have along a few years. I don't remember exactly how many, but they did that, and they continue doing the same program. That's what I can tell you in a very general form now today.
Okay, thank you very much by your participation and your interest and the question that you have asked to the rector. Now we go with the closing ceremony. Thanks.
Sure. Are you going to use the screen? Oh, okay. Hola, ¿cómo estás? Bueno, eso. Well, more or less we are on time, so not so bad. Could be worse. So
it's the first time in the conference.
Okay, I did my best. Anyhow, well, it's time for this closing session. Finally, the conference is coming to the end. A lot of things has been happening in the last 3 days. You have been working very hard, many sessions, many papers, many social activities. So I guess that in addition to that, many good conversation among you related to this or other topics, because World Conference has the ability to make an easier communication among the participants. And now it's time to go to the end, and I'm going to give you the floor now to Professor Manuel Castro. He is one of the co-chairmen of the conference. I'm going to say now a few words. Professor
Thank you very much,
Castro.
dear Rector, dear Javier. It's the time to close the conference. We started 2 days ago. We start this conference near 300 people. I'd like to thank to all the 300 people registered in the conference. We have more than 250 contributions. We have people from the 5 continents. We miss people from the Antarctic. We have people we are involved with people in 100 people in the committees in the conference, 300 reviewers we have for the conference. We are involved with 4 large institutions, like myself, the UNED, the Polytechnic Universidad de Madrid, the CTI from Austria, and mainly the IEEE. We like to thank the IEEE, mainly in the persons of Susan Lord, that the president of the Education Society, and from the Ruth Meyer, for the meetings chair that are here in this. I'd like to make really thanks to Javier Uceda, the rector of the Universidad Politécnica de Madrid, for all the help and the support that the UPM give to the conference. I'd like to thank to my rector, to Juan Jimeno, that opened the conference 2 days ago, for all the support that we gave from the Universidad Nacional de Educación a Distancia too. And finally, I'd like to thank to my 2 co-chairs, to Edmundo Tobar from the UPN and to Michael Lauer from the CTI. I believe that we make a lot of work. We start this work 2 years ago. We are making 2 years of work to finish today. We are involved to more than 2,000 people involved in any aspects of the conference, and I believe that we make a lot of work. And except some bits of rain that we have the first day, I believe everything more or less worked in the way that we expected. To close this my talk, I will make the final awards. We have some awards for the 5 different categories in the conference. The award mainly is a certificate only. We didn't have any prize and so on, but this is a quality high award. We have 5 different, 5 different areas. I will only say the small summary of the paper of the award for each one of the 5 areas. If he's here, please stand and we'll make a claps. First area is infrastructure and technologies for engineering education. The paper award is ranking learning collaboration. Antonio Anaya. I don't know if he's here. He's not here. It's okay. It's a award in this case. The second one is 3 online neutron beam experiments. Kimberly DeLong from the MIT. Is here Kimberly? He's not here. All people is not really tired rest.
They don't expect such.
Yes,
nice
yes, sure. We will send later the certificates to them. I will put in the website. Area 2, innovative materials. The award is for wireless 4x4. Carlos Figuera. He's not here either. Area 3, students internship placement from Rafael Garcia Campos from the Knowledge and Competency Engineering. We are all missed award there. 4 is here.
Well, this is homogeneous at least.
Yes. 4 is here, area 4, educational methods and learning mechanisms, ensure program quality. Mudassar Wine, I saw him a little bit, no? Ah, yes. Mudassar. You have 4 more claps from the previous ones. And finally, area 5 is attracting, engaging, and retaining human talent. The paper is Spirit Alive Cycle, Barbara Barr. She's not here too. We have one special this year innovation category for innovation engineering education. The award in this special category is for game-based learning, Marcus Gunter. He's not here either. Okay, and to close all these awards, we have a special award for the doctorate. Doctorate students have made some specific papers. We have near 40 papers from doctorates, and we finally, after a lot of decisions, we make 3 co-awards. First one should be for Sheila Martins. It's not here.
Us.
Yes. The second co-award is for Danish Nadim for the Open University of Netherlands. He's not here. And third one is for Elena Ruiz, that is for my university, for the UNED. I'd like to congratulate to everybody and thank you too much to all to be here, and we'll continue being the next year in the next conference that will be announced later on. Thank you very much, Rector.
Now it's time to present the next edition of this conference, and now I'm going to give the floor to the meeting chair of the IEEE Education Society, Russ Meyer from the University of Milwaukee, USA. Russ.
Ladies and gentlemen, it's been my great pleasure to be with you here in Madrid. I've met many of you that I did not know and reacquainted with many of you that I did. The IEEE Education Society and the IEEE as an international organization has been more than pleased to have sponsored this conference and to start this conference series now in IEEE Region 8. Over the last couple of years, I've worked with the three co-chairs, Manuel Castro from UNED, Edmundo Tovar-Caro from UPM, and Michael Lauer from CTI. Please join me as participants in thanking these three co-chairs as well as their universities and the city of Avila for the wonderful, wonderful conference that they've given us. Manuel asked me to very, very briefly introduce next year's conference as sort of a pre-call for papers, so you would know where it was and what the dates were in case you are interested in contributing to that conference next year. I'd like to thank Michael Lauer, who is the EDUCON Steering Committee Chair, for putting together this slide set that I would present today. He had pictures from the host institution from an event that he attended there recently. And we're very, very excited to let you know that EDUCON will indeed be moving to Amman, Jordan next year from the 11th through the 13th of April. The vision statement for this conference is that EDUCON will be a premier forum for academic, research, and industrial collaboration for global engineering education, which is one of the themes, of course, that the rector included in his presentation today. This globalization that's occurring of our field across boundaries and cultural norms. Our location statement is that we will rotate EDUCON through three major subsections of IEEE Region 8. Europe, followed by the Middle East, followed by Africa, and then back to Europe. Next year, of course, we'll be in Amman, and as you can see, a nice city shot here of the city of Amman. And specifically, it'll be hosted by Princess Sumaya University, which has very nice conference facilities and lots of hospitality, as you can see some of the facilities that we'll be in next year. Social activities, of course, including lots of traditional things from that part of the world, including lunch in the Bedouins' tent, tours perhaps to the Jordan River, or to the UNESCO World Heritage Site of Petra, or to the Dead Sea. So we hope to see you all again next year in Amman, and thank you for your participation.
And now let me introduce to you Pedro Aranzadi. He is Director General of Universia. Universia is a network of universities, mainly Latin American universities, more than 1,000. And they are doing a wonderful job through this Universia. And that's my pleasure to introduce Pedro Aranzadi. Pedro.
Thank you very much, Rector Magnifico, Mr. President, co-chairs, ladies and gentlemen. Just wanted to thank you all for being here, for especially the IEEE and UNED University and Politécnica de Madrid for thinking about us as possible sponsors. We're very proud of having the opportunity to sponsor sessions such as this. A few words about myself. As the President said, I'm Managing Director for University in Spain. I manage technology for 23 countries in which we are present, which, as I always say, for an economist, you can only speak of terrible karma, I guess. University, as the President says, is a network of nearly 1,200 universities in these 23 countries in which we are present. We are part of a social responsibility program of Banco Santander, who is our sponsor. The main bet for the bank in their social responsibility program, I guess that the thing is that they see that investing in education is the best factor to develop in any country, any place. And well, that's what we are. What we do is try to help, if possible, the universities in the countries in which we are present in new technologies and new ways of teaching and serving them in whatever way we can. We are very proud of having president of the Universidad Politécnica of Madrid in our executive committee and board of directors. And that's pretty much about it. Thank you very much, and I hope you had a wonderful experience here in Madrid.
Thank you to Universia for its support. They used to support many activities in universities, and it's very helpful just to have this initiative here in this conference. And now it's time to introduce to Professor Zulima Fernandez. She is director of the ANECA. ANECA is the National Agency for Quality and Accreditation here in Spain. They are doing a wonderful job just trying to change the rules of the university system. We are just working together right now according to this Bologna process in Spain. While they are doing ANSES, just taking care of all this stuff together. And it's my pleasure to introduce Professor Zulima Fernandez.
Thank you. Good morning, also in my case. Rector, academic authorities, colleagues, ladies and gentlemen. First of all, I would like to congratulate the organizers, especially to the rectors, Uceda and Jimeno, for the huge effort done and the success in mobilizing so many experts, as well as in the number and level of presentations submitted to this conference. This is the first event to be celebrated among the 5 proposals selected in ANECA to co-finance the organization of seminar and conference this year. The first one, in fact, since I took over the responsibility of leading ANECA. This is my first meeting. Innovation and new teaching and learning methodologies has been one of the 3 topics which ANECA wishes to focus on this year. According to the success of this conference, it could not be a better beginning. The conference goes to the core of one of the current interests in the Spanish higher education system and the adaptation of to the European higher education area. Traditionally, the Association of Faculties of Engineering have been at the head of innovation, of teaching and learning, also at the national and international level. And the results very often have been used as good practices for other disciplines. However, the cooperation between ANECA and the Spanish universities in this international conference is not only focused on contributing to the funding issues. The real cooperation has been shown through the participation of experts coming from the technical staff of the agency and also inviting colleagues from the accreditation organization on the European setting. This is the case of a member of the French Commission of Engineering Degrees. They took part on the roundtable sessions of the conference, bringing the experience from the evaluation and accreditation viewpoint. This issue is also important to assure that the existing devices to evaluate the programs do not hinder innovation and creativity in the new teaching and learning context. I would like to stress that ANECA also receives a very fruitful reciprocity, having the opportunity to incorporate the results of the conference in the working lines of the agency in order to improve its programs. In this way, the collaboration between ANECA and the Spanish universities allows bringing to our context those best practices from the international arena. Thus, we can contribute to the internationalization of the Spanish university system. This can be done in part because of the privileged situation of ANECA in the last year at international bodies. Since its external evaluation by the European Association of Agencies, ENQA is the name, ANECA takes also part in the executive boards of the European Consortium for Accreditation and, in other contexts, the Latin American accreditation agencies. Just a month ago, ANECA has been awarded as the first European agency to fulfill the guidelines of good practices of the international network that works at the global level. This privileged position, as I say, allows ANECA bringing the last advances in quality assurance to the national debates. This perspective matches also with the wide range of topics on the session, of these sessions. They show that most of the learning settings in engineering have been systematically treated. Therefore, the conference has been a meeting point for professionals of the engineering sector promoting networking. Finally, I would like to say that ANECA will contribute on the future to support these events organized by the universities for building an international dimension and improving transparency for the benefit of the university, the university system, and also the society as a whole. Thank you very much.
Well, almost everything has been already said. I'm confident that today we are one step forward than 3 days ago in engineering education. Thank you very much for the work carried out. We need your work, we need your activity in order to improve our education in engineering. And I would like to thank to all for the work carried out, to the organizer, to the sponsor, to everybody. I hope you enjoy your stay here in Spain, in Avila and Madrid, and I wish you have a safe trip back home. And that's all I can say today. It's too late, it's time to go for lunch. Thank you very much, and good luck. That's all.